I'm Kevin Carpenter. So I work for a company called Electronic Payment Exchange. We're a credit card processor, and we're called an acquiring processor, and I'll kind of get to what that means. We're owned by a bigger company called North American Bank Card. So our particular company, we're kind of small, about 30 people, and we write what they call a platform, which all of our credit card transactions are processed in. All the other stuff there, been in technology for way too long. I probably spent most of my last time in financial modeling, about 8 years doing that with credit unions, and the last 7 years or so doing credit card transactions. I'm a lead project engineer on our team, and so this talk is going to be a case study about what I do. I've been writing RESTful interfaces for about the past 4 to 5 years as we've been updating stuff. So we're going to, have a little background. We're going to do a little history. Then we're going to look at what a RESTful API is, kind of the basics of the architecture. We'll look at some simple REST calls and kind of how REST works that way. Then we'll look at the JSON library we use, the HTTP library we use, and we do have actual C++ code. So everything that I'm going to talk about here, there's a project available. You can download it off GitHub. The source is already there. And so you will be able to build and play with the code and check everything out. All right, so we're in the middle there where it says acquire or EPX. This is kind of a map of the way transactions work. So at the top, we have web terminals or physical terminals, and API is the part that we write. So if you can imagine, that's what a merchant uses. So if you're on a web shopping site, that's a web page, you put your credit card in, it talks to an API, or if you're at a coffee shop and you tap, that goes to a credit card terminal, it still comes to an API. Those are all merchants. Normally, dinner is my favorite example, because when you're at dinner, you give them your card the first time. In the US, they take your card away. Here, you simply tap it, and it does an authorization. In the US, they'll turn around and sometimes take the card, they do initial charge, but it's not what we call settled. It just ends up doing this authorization to make sure there's enough money on the card. At the end of the night, all of those get totaled up into what we call settlement. So even though a lot of times when it comes to a credit card transaction, you think you're just tapping it, you can actually see in your bank statement a lot of times. That's where it says like pending versus when it's settled the day later. So when the transaction gets tapped, it comes to us through the merchant. We turn around and go out to the network and say, hey, is this valid? Is the money there? And then we feed the whole thing back. Interestingly enough, we get 22 seconds to do this. Beyond that is where the Mastercard company or Visa say we have to fail. But generally, as you know, it happens within a couple seconds, if not less. All right, so how many know their CRUD operations? Create, read, update, delete. Yeah, all right, so this is probably looking pretty basic, but we'll play some fun. So we have a get operation. It meets up with what? Read. Yeah, all right. And then a post operation would probably meet up with what? Yeah. All right, and a put operation? I was going to say, when you know delete's going to be delete, it kind of makes that last one. It's not that hard to figure there. So that's kind of the thing that I think is interesting with REST interfaces. The HTTP verb matches up almost directly with your CRUD interface, right? And so that's kind of one of the building blocks, at least to me, that you're using when you're doing a REST interface. So what is REST? Representational state transfer, courtesy of Dr. Roy Fielding here. It was part of his doctorate dissertation. The thing with REST is that it only adds high-level rules to how an interface is built. How you do it under the hood, that's all up to you. A RESTful interface is supposed to have 6 constraints. It's got to be client-server. It should have a uniform interface. It should be stateless, and I'll kind of look at that one because that means that the server side should have no state operations. Cacheable, because we want to be able to save time on the web. And then layered system, you're passing a transaction in, it's going to go through various layers before it comes out. The last one, code on demand, is really kind of a cool feature because if you're doing a REST call, you can actually pass down binary code to cause an update to happen on the client end. So we'll look at the client constraints first. So in my world, these are our clients. Like I said, we have web pages, which can work with a phone. Incidentally, that phone can also work with the puck or hard terminals, okay? And these end up talking to a RESTful interface, such as create. So if we have a create operation, we would do a post to a URI endpoint like sale. And that's gonna have a JSON payload in it with various pieces of data, and we'll see that. And of course, that's gonna create a record. A read would be a get. So when we do credit cards, like I was saying, if you're at a restaurant, they have a whole bunch of transactions they do for a day, and we'd have a batch ID for that. So at the end of the day, they can actually make a request with a batch ID, and it's gonna return the JSON. There wouldn't necessarily be a payload because all the information that the REST interface needs would be right there in the URI. It's a get. You're doing it to batch with a certain batch ID. It's gonna return a bunch of data to it. And that's kind of the whole thing with the RESTful API. It's trying to make the API intuitive to how you would do calls to it, right? So an update. So in this example, we're gonna do a put. I might be trying to void a transaction, and so I would use a transaction ID. I might have a payload with a put if I was doing an update, and we'll see an example later that's not a void. But either way, it's gonna do an update of a record. And then delete. If we delete a transaction, same kind of a thing. I might do a sale with the transaction ID. There wouldn't be a payload because I'm trying to delete something. And at least for us, you're gonna get a 405 error because, I don't want you to be able to use your credit card, initiate a charge, and then suddenly delete it from our system. So we don't use deletes. All right, so on the server constraints, generally, any kind of a server thing we're going to do, you're going to have web server hardware, you're going to have a database for storage. I think that's pretty clear. But we need a uniform interface, and so we're going to look at some more URIs. So again, here's an example. You might get with a sale for a specific good. If I use the word brick, that's a business term. We use them interchangeably. It's a unique ID, absolutely unique. That might get me the ability to look at the previous sale. Posting a sale, if I have a JSON, I'm going to post or create a sale. Sale, GUID, capture, in that case, I'm passing in a unique ID. I'm going to do some sort of an update. Another quick set of examples, refund. So if I pass in a specific GUID, I might be trying to do a refund or see if a refund occurred on that case. Posting a refund would be creating the refund. And like I said, we don't use delete. So in the case of our API, if you wanted to void a transaction, you would take a transaction GUID that existed and do a void. Now, again, much to my wife's probably miscontent, I get credit card receipts and look at them, and so this is just kind of, but this is what I love. Like when I look at a receipt and I'm like, I wonder how this went through. But from a RESTful API building point of view, I'm just trying to show the fact, however you build your RESTful interface, you want to have a uniform interface that, again, you can have an intuition about how you're going to use it, right? So like I said before, stateless is one of the other requirements. So any one of these particular calls is going to be complete in and of itself. If there's any state maintained, that should be on the client side. I do have a caveat to that we do, which we'll get to later, that has more to do with headers and authentication. So it's not so much session state as it is the security of a transaction. Cacheable. So if we're doing a get, like earlier I had the get with the batch ID, right? So if for some reason a merchant wants to re-request how many transactions they had in a day over and over, we don't want to have to send all the way down the server back to the database each time. So to be able to cache it in the middle so that we can return that data quicker, that's just smart, right? We get a faster transaction turnaround. Layered system, as we can kind of see, servers, interfaces in between, so our layered system. And the code on demand. And again, I think that's a really cool feature, but it is one of the ones that he listed in the dissertation as being optional, and it's just one that we don't actually use for ourselves right now. All right, so we're gonna look at a few REST examples. So how many of you know JSON, or at least have seen it? Okay, so pretty much everybody's raising their hand. Great. So JSON example, this is actually a very basic, this is all I actually need to process a transaction. I'd have the account, the expiration, the amount. The batch ID isn't even required and the transaction ID isn't required. So when it comes to even using an API for credit card transactions, you can do a lot with a minimal amount of information. But it's going to be a post, and so that would get posted via web client to the server. The server would do some processing, and you would turn around and get back, in this case, an approval. Now, the part that I want to point out is there's not just the payload coming back with the information, but the return status code, right? We got back a 200. Because in some cases, if you don't get a payload back, that status code is all you need to be able to tell you if the transaction was a success. So a put example, real quick, you'll notice our brick that we have there, which, like I said, to us, brick is the same as a GUID. So this is where I'm saying, inside of our URI, we actually include that. So in this case, I'm taking that previous transaction and I'm going to add a tip. And so I'm telling it to, send that off as a put. Again, it kind of processes and it comes back, in this case, an approval, 200. And at least in ours, you now get a new brick. You would get some new unique ID so that you can continue referencing. And that's how we've built these interfaces. And it's important for credit card transactions because you might start with that initial authorization, but then, like I said, in at least credit cards, we have the part where it settles, the part where you might want a refund, the part where you might want to void it. And each one of these has to chain on and be able to track. So by every transaction, there's no session held on the server, but that doesn't mean that we can't walk back because of the way we designed an interface all the way back to the initial transaction. All right, and our last one we'll look at, we took the GUID from the previous. We're going to do a delete. You see the three little dots because we wouldn't have a payload. But it goes to the server, it does some processing, and we get a 405 not allowed because you can't delete your dinner transaction. We won't let that one happen. All right, so that's the basics of those items. We're going to go through some background. We were upgrading XML-based systems when I came in and started taking these particular projects over, and we're moving them to JSON REST API. Previously, I did a talk about 0MQ in JSON, and I'll quickly cover what we're doing is 0MQ or not. Header only. So the libraries we're going to talk about are both header only, and why for us that actually matters. Performance considerations, of course, because we use C++. You might be surprised at where this ends up coming out, though. And so these are the two libraries that we use. We use nlohmann JSON, which is JSON for modern C++, and cpp-httplib. And so we'll look at the pros and cons. All right, so why JSON over XML? I actually never really had a problem with XML. I don't like parsing it, I'll definitely say that. But there were some decent XML parsers. But if this is all the same account data, right? It's the same fields and everything else. For me, the right side is easier to read. But the more important part is that if you look at account number and account, you have 43 characters versus 30. Card method is 32 versus 23. And we tried to, this is exactly what I was replacing. So overall, you end up with almost a 20% savings in space. Now, there's other benefits to XML, but for us, when you're processing millions upon millions of transactions, 20% of space is a good savings, especially when you're talking turnaround times from, we have fast internet connections here, but we have places in the United States where there's still, you're putting your credit card in and it's dialing up over a modem. And that anything you can save in space is good. All right, so in 2018, I did a talk at CPPCon called Scaling Financial Transactions Using 0MQ and JSON. Those are the links there if you want to watch it. 0MQ is a message queuing protocol. It is really fast for passing messages back and forth. It's a reasonably compact library compared to some of, I think RabbitMQ is one of the other ones that was out there that we considered. We do still use 0MQ, but we use that more so that our platform can communicate. So for a credit card platform that we have like 70 plus little programs. Each one, because American Express protocol is a little different than Visa. And so all these little programs work together to make our whole platform. They communicate, letting each other know they're up using 0MQ. But when it comes to actually processing transactions, we need a RESTful interface that everybody can access, and hence we use JSON with HTTP. I had this note that JSON and REST go together like peanut butter and jelly. And depending upon what country I was in, I realized that peanut butter and jelly is not quite, I'm not putting Marmite on my toast, so I'm not using that example. But in the US, peanut butter and jelly go together pretty well. All right, why header only? Because size matters. We're a small team. There's 10 people on our actual development team that build this platform out. And so, as I'd mentioned, the libraries that we use when they're header only, they're easy to follow. We have one file to worry about. Bigger part for us is minimum dependencies. Each one of these libraries, when we started with them, just had to be C++11. Features have come out. C++17 is better, and even 20 and 23. But I believe on both of them, even C++17 is the only requirement. And the bigger question when we look at libraries is, can we maintain it ourselves? So as a company, we wanted to make sure that since it's an open source library, if development slowed down or stopped on it, it's something that we can still, as our team, pick up the code and continue maintaining it internally. So when we started with JSON for modern C++ from nlohmann, it was 13,000 lines. And that was several years ago. It's now over 24,000 lines. And then likewise, the httplib was 3,000 lines when we started, which was really kind of cool because we were through it really quickly. And now it's over 9,000 lines. So they have grown, but they are still single headers. If you look at the nlohmann library, you'll find that you can it's broken out, but you can still amalgamate the file all together. So it's one huge file. But we've also grown with it. So we're still in that spot that we can maintain it ourselves if we needed. So JSON for modern C++, there's the URL for it. nlohmann was the initial creator of it. Of course, all open source projects have hundreds of contributors. This is Milo. So how do you compare JSON libraries on speed and performance? He actually wrote a benchmark that you can turn around and download and run. And we'll look at some of the scores from that. The scores we're going to look at from his benchmarks are from 2016. I worked to rebuild it, but on the M1, I was getting some compile errors. But I have found that those values haven't changed. It is fair to say also that Milo wrote Rapid JSON, which is a competing product. But I think that the numbers that he gives in his comparison are just real. I don't think that anything's been doctored in a way. So the one thing about JSON, and I've been corrected a little bit on this, but generally when I look at it, you can't comment in a JSON file where you could in XML. You can't do error handling within the file itself where XML had the DTD style sheets, if I recall, which were nice. No date type, which, so dates, at least for us, are coming through as either an integer from some specific point in time or a string. So in some cases, you could say it's not as robust, but I think the world has kind of looked at it, JSON as being the way to go. I skipped over it, but it's like, there isn't many languages that don't have some way to read or write JSON, right? And so when we're bringing stuff in, it's kind of the way. All right, so you can see here, Rapid JSON from a conformance from the benchmarks that Milo had created was at 100%. And in 2016, the nlohmann library was only at 96. So we never had a conformance problem, at least in the items that we run. And I get a decent amount of junk data from new merchants signing up, new people trying to use the API. We never had a problem that way. From a performance standpoint, if Rapid JSON took 8 milliseconds to parse, we had nlohmann's taking 72. So, not quite 10 times difference, but the nlohmann library, you're not picking that for speed. And you're going to pick the nlohmann library for ease, and we'll see that in the code. The nlohmann library is one of the easiest ones to use. And this slide, you'll notice, is quite different, not like the rest of the deck. And the reason is Maya Marikovic gave a talk just yesterday where she was comparing JSON libraries. And so if you want to see more about speed comparison of libraries, when we get the talks online, you'll want to watch her talk. But the reason I borrowed this slide from her after her talk was because the speed hasn't changed between nlohmann and Rapid. Rapid is still faster. But in her talk, she found that Glaze is even faster than Rapid. So if you are looking for speed, Glaze is a library, I guess it's a little newer. It's one that I'll end up checking out. She said it's still not as easy as Niels Lohmann's library, but it is a new competitor to look at. All right, so for our HTTPlib, it's cpp-httplib. Client server, that's the URL for it there. The thing with cpp-httplib is, like Niels Lohmann's library, it's very easy to use and get started with, but the client side of it is blocking. Not the server side, but the client side is blocking. So if you wanted to have an asynchronous client call, you're going to have to wrap the client yourself. There is a RESTful CPP benchmark for it. It doesn't tell anything different than what I'm saying here, which is, we picked our libraries for ease of use and ease of implementation. Like I said, I have to complete a transaction in 2.2 seconds. That's not getting slowed down by the HTTP server or by the JSON size generally for us. So I'm really lucky. The HTTP lib does support OpenSSL. I'm saying I'm lucky because with where my apps sit, I have all kinds of load balancers sitting in front of them. And so I don't have to deal with OpenSSL because they take care of that for me. You can see that the library does use OpenSSL. There's great documentation for it, but you won't see me covering it anymore as we go forward. All right, so that's a bit about the two libraries. And so the approach, we're gonna look at and build out a basic HTTP server. We're gonna talk about some of the REST practices and build some endpoints into that server and see how that would work with the HTTP lib. We'll create an HTTP client, which we'll use to test that. And then we'll talk about some of the lessons that I've learned over the past few years as I've done this. And so on to code. All right, so looking at this slide, you'll see that it kind of resembles if we were looking at something in Visual Studio Code. And these are the bulk of the files that we're going to go over. The orange arrow here is going to move up and down as we swap between files. And again, all of the source code here, I'll give a link at the end. You can download it, it builds, it compiles. I'll even show a live demo of it. But that's just to give an overview of where we're going to be going over the next slides. This include of app.h. So it's a scaffolding supporting class. Like I said, we have like 70 plus programs. And so, when you have that many little programs, you start to build up a library to be able to handle things like how the app starts up, how it handles configuration files. In the 2018 talk, my company was kind enough to let me take part of that scaffolding, including some of the 0MQ stuff, and release it. And so if you were to go back and look at that URL, there's a GitHub for that. The code is still there. So when I made this particular demo app, I just continued using that. We have improved our base scaffolding, but the JSON or the part that's here has not been improved. So if you open that up in Clang Tidy, it's very colorful, we'll just say. But it does work. So what I want to focus on, though, is how we're using JSON and building REST interfaces. So I'm not meaning to glaze over some of the app stuff. It is in there. You can walk through it and see everything. And I invite you to when you download it. But if I skip over some of those things, that's why that is. No. Sorry. So looking at this, that said, looking at this, we have this class RESTful, which is our base application coming from this restful.cpp. This is going to be the base app. We'll have a binary called RESTful. And as you can see, we have a setup, we have a start, we have an idle, not much to the header. The setup, we'll look at how it loads in. You'll notice that it's taking a JSON object. and that is part of the nlohmann JSON, as you can see from our include JSON.http there. The start is how we're going to start up the server. And the idle, in this case, we build and run everything on Linux. And I know some ways people run daemons is different, but for us, the way we end up doing it is the idle is going to keep this app going while the HTTP thread answers. And we'll see exactly how that looks in a few here. All right, so looking at the RESTful CPP side, this is, if you look at the top, we got like version and app name and log line. And so let me go with the version and app name, as well as if we look down at main, you can see how I'm instantiating this RESTful with the app name. And this is part of that scaffolding that I said that's going on. So in general, it just takes the command line arguments in and it calls that app main, which is inside the scaffolding. Part of what that app main does, though, is it ends up doing this run method that we see here. When we do the app run, it also ends up turning around and pulling in a JSON config file, which we'll look at. You'll notice that we have our idle there. And as you can see, all the idle is really doing is every 5 seconds, in this case, it's logging out a line that says idle. So we actually do this because when we're running transactions and running these servers, we do a lot of our network people will tail log files because aside from running things on a load balancer, we do a lot of A, B, C type splits because we have centers in different parts of the world. And so they actually want to be able to see that the server is or is not getting a transaction. And so even though it seems odd, having that line that pops in saying idle, idle, idle lets them know when they've pulled traffic off of one spot versus not. And so that's the way they end up doing it. So this new here without a delete, right? Must be bad. And it probably is. But in this case, if it crashes from here, the operating system's cleaning it up. And so that was, somebody had pointed it out when I'd given the talk before. They're like, you have a new there without a delete? Yes. It's the only new that you will see in the code, though. All right, so when we start up the actual app, you'll notice here, so if you notice in the corner there, I have that RESTful JSON. I'm going to back up a couple slides here. So you'll notice we also have the app name of RESTful, and we're going to see, the third line down there. What we're going to see is that part of the way our app framework works is that when it starts up and does that run, it looks for that file restful.json, which is our config. And so this is a two-part thing. This is how we happen to load configs, but I also want to point out the fact that this is where we're using the nlohmann library to be able to pull in a JSON config file. So we don't just use the JSON for the actual RESTful interface. For us, we actually use it for the config files too. So as we start down here, you'll notice we have a structure called host, which is HTTP host. In that, we have a setup method. We're going to get config at HTTP server. So that is actually going to pass in the IP, the port, that whole substructure of JSON gets passed in as a JSON object. So we just start, we have a simple line that's going to be logged out saying we're starting the server. We then start the HTTP listener run. We pass in the host from the structure there, and then we're going to detach. And so we're doing the start here, and we detach when we start the thread, which is also why we have that idle running, because when we do the detach here, the idle will keep the binary from exiting. Okay, so looking at the host structure here, you can see that we're pulling in the nlohmann as a using. Simple struct, we have this setup function in there and the isBand. You'll notice the unordered for band IPs. This just happens to be, sometimes I'm using an example of band IPs here, but this isn't a configuration. So you might configure to ban certain IPs. We also use it because, like I said, we have a lot of load balancers. They'll do checks. And even though we like idle lines, we don't like noisy lines from a load balancer sending in a check. And so you could look at doing that either way. But from the previous slide, you'll notice that, yes, we're passing in the JSON config option, config object. It turns around and looks at an at for each one of these by doing config at IP or config at port. which is different than you see where I do config contains. So add is not as safe as a contains or a value. And so the reason we end up doing contains is because if the band IPs isn't there, that config value will still turn around and set band IPs to an initialized blank unordered set. So one is a bit more safe. If I didn't have an IP in my config file, this would actually crash out, right? And that's what the difference is going to be with an at. So depending on how you use the library, there's various ways to access the data inside. But the thing that we like about the nlohmann library is the fact that it's just, to me, it's intuitive and it works well and similar to how you would do things within the standard library, which I think is the part where it is listed as one of the most easy to use libraries out there for JSON. All right, so here we're into our HTTP listener namespace where we have the run. Down on the bottom there, I'm just trying to kind of give you a link back to how in that initial app we were calling that particular line. And so we're passing in the host structure. Here is the first time you're seeing that we're actually including httplib. And so we have the httplib server. We're creating the basic object there. And we pass that object into this handler setup, which we'll look at, of course, in a minute. We're passing in the server and we're passing in our host structure. And then we tell the server to listen on that particular host and IP. And so when it comes to setting up an HTTP server with this library, I find it really simple. I mean, hence why we're using it. But this is minimal for a reason. There isn't actually much required to start the server up. A lot of it comes into your configurations, which we'll go into more. All right, so this is collapsed. We're going to break it apart one by one, but you can see the setup here, which is where we're moving on to next. So we have the security, the errors, and the routing, which are three separate methods we're going to call. And on each one, you'll notice we're passing in the server as a reference. So that's that part. When the setup is called, it takes that server object, and we're going to do various things to it to set it up before we hit that listen point. We're also passing in on the security. We're passing in the host port. And so if we start off looking at the routing, this is also where you're going to see that we are starting to set up our RESTful API. Okay, and so the way the routing works is the pattern that we're using here in the, so you can, okay. If we look at the server being passed in, we turn around and do server post. So you literally are taking the server plus the verb, the pattern that you want matched, and then what is roughly a handler to stood function. And in this case, we're using lambdas just because it's nice and we find it a tight way. But with it being a stood function, you could actually, do so much more with it. So in this case, if we get a post to a sale, then the parameters that we end up coming with it is this HTTP request and response. There are some places where I'm being specific and listing out like the request and response, but there's a lot of places you could replace with auto, and it just works well too. So if we get a post, a sale, we're going to call API sale and auth with the request and the response. Same thing here. If you look at the put, here we're using an actual regular expression. And you'll notice that we got a capture in there. And that's kind of that spot where we're like, okay, so if you were going to do an update on a transaction, you might capture something in the URI. And we'll see how that ends up happening there. Get on a sale. So we'll end up looking at how we end up returning a list of data. And then the delete. And so, like I said, normally in our interfaces, we don't use delete, but I wanted to give an example that you could actually use instead of just returning a 405. So this does have a complete delete. So for security, same thing, we're passing in the server and we have this host. And the thing I guess I really want you to look at and focus on is you'll notice we have the server.setPreRouting handler. And that's that whole part where when it comes to building the server out using the httplib, you're actually kind of designing the functions that you're going to pass in and setting it up that way. Once you turn around and do listen, everything is just up and running. So in our case, we actually take the host, and I've been glossing over this F name of logline. Clang Tidy it gives an error message. So that static cast is to prevent a bit of the noise for it. There's easier ways to do it. But for the most part, we're passing in the host. I pass in the function name. We'll see how that ends up looking. But whenever we're doing stuff in a RESTful interface, if there's something going wrong and we're getting connections in, we want to be able to log the function name that we're in. And so it makes for a nice log file to say, hey, this is the function you're in when you're receiving a piece of data. So we take the request and we have this set ID. And the thing I need to point out about this set ID is this is not part of the httplib. I've got a pull request ready to send to them to see if we can end up adding it. But when you get a request, the request that comes in is const, so you can't necessarily set something. So we actually added a feature to set an ID. Because for us, we want to be able to track, it's not as much about session tracking as to be able to look at it and be able to say, okay, this is the exact transaction ID that goes through. So this is specific to the httplib that I have in the source checked in here. That is not inside the actual open source library yet. So we turn around and grab the IP address, the user agent, and back to host. This is where we're passing in host to see if it's banned. One of the lessons learned, which I'll kind of go over quickly now, is that there were a lot of places when I was working some of this original code that we were using singletons. And so we would, or a global const object of something. And of course, not even global const, but just a static object of something. And so the problem there is, of course, somebody else could change it. And so one of the things we found was safer is to turn around and use more of a dependency injection method and pass in our actual dependency, which of course then makes it less tightly coupled and less likely that someone tries to change my IP address out from under me. Because generally speaking, once I hit server listen, you're not going to change that IP address. So we're going through here and we check to see if a IP is banned. You'll notice on the return that we have HTTP server lib handler response either handled, because in this case, if the IP was banned, we're going to return back out of this saying, hey, we've taken care of this. And that's going to tell httplib that it just needs to cut the connection. Since it's not banned, as we would flow through, then we would do unhandled. So when you're inside some of these pre-routings or some of these other methods, you can tell httplib whether you handled it and it can just stop its actual flow, or if it needs to continue on with the next item. So there is also a set post-routing handler, just as you have a set pre-routing handler. So pre-routing is, of course, before it ends up doing the routing. Post-routing would be after it did everything else if you wanted to log some final message out or do some other final cleanup. So for errors, similarly, there's an error handler. Any kind of error, set error handler, passing in, you'll notice that it's similar in the way that the others are set up. We're just gathering as much information as we can, and then using our logger class, we end up logging it out. That logger class is a singleton that we use, and it works well because we can just do this get logger and it pulls in and we can end up accessing it. But of course, part of the problem with doing this is that it makes things tightly coupled. So I have actually had that bite me. Okay, so we're going to start looking at this, at how we're actually processing the RESTful part of the API. So we're looking at the sale CPP. And so, I set a content type because it's something that ends up getting passed back and everything. The log line is similar to where I was saying. We set up our logging so that you can be, get some good messaging as you're saving things out. And so we're looking at the auth request first. And so you'll note that the auth request was the /sale. So I point out this fact of the log and logger because just like I was saying about tight coupling, one of the problems with this is, can you test this easily? Not really, because if I go to do a unit test on this, and this, I recently found this, it bit me because I actually have to have that logger all set up and log out. Where if I actually did a dependency injection and passed the logger in and did some other layering with it, I could have one type of logger if it was a unit test versus actually the real logger when we're doing a production item. All right, so we get rid of that, hand it in as a dependency injection, that would be the better way to do that. Just to say, no, that isn't how it is in the GitHub right now, but the code in the GitHub runs. Okay, so calling out this line, you'll notice we do a JSON parse on the body that's being passed into us. So we get the request, one of the properties on request is body, and that magically gets turned into a card info object, which we'll look at in a minute. And with that card info object, I have a little utility that's kind of meant to represent generating a GUID, so it will hold the GUID, and then we will store that into a data store. That data store is just a simple map with a mutex, so it can work multi-threaded. It's meant to be an example of, if you were passing down a chain and storing a transaction. So it's meant to be for demo, but obviously you would do a lot more with your data when you're building your own RESTful interface. So, sorry, real quick, and then once we store the data, I'm logging out that the sale has been posted. And again, I'm setting the status code. So we end up writing out that this, in case it's going to be a 200 OK. The JSON result is created from that structure, card info, and the set content. The result.dump takes the JSON result and sets it as a standard string. That's what the dump method does. And content type is because set content as the return result for httplib needs the content type as well as what you want to return. That right there is actually the end of the httplib request. So once that goes out, it'll set back your 200, go right back up the chain. httplib is now done with that transaction, and that's it. Okay, so let's look at that card info, because what we're going to get to now is, and I'm bouncing back and forth on this because I want to explain how the app works, but it's also the part of, here we're going to look at some of the niceties that we like about the nlohmann library. And so we have this card info struct, which, as you can see, is just a basic struct with strings and doubles and unsigned ints. The part that's actually neat about it is this from JSON and to JSON. And so the from JSON and to JSON, this uses argument-dependent lookup to be able to auto-magically convert your JSON structure to a solid data type. And there's been various areas when we first started this that we were just passing around the JSON as a string, right? Because I could pass the JSON to something, I could turn around and pull it up as a, do the parse on it, get access to the individual items, and it was all great and wonderful until you realize you're always passing around a string. And, that ends up being an issue compared to using a solid type. You end up passing a string everywhere, it's hard to tell if you're passing the wrong thing. And so we make a lot of use of the serialization options of the from JSON and to JSON. So in the from JSON, you can see we're taking our structure and basically getting the value. You'll notice I'm doing the JSON.value instead of at. So the .at, like I said, if the value's not there, it's going to crash out. And yeah, you could try to catch that with an exception. The exception handling's pretty good. But in this case, I just end up using JValue. If the tag is not there, it's going to default initialize with the value that's there. The to JSON is doing just kind of the opposite. It's going to make a JSON object from the structure as it's passed in. Now, that's a lot of boilerplate. And so there is a set of macros inside the nlohmann library, so you don't have to necessarily do all of that. But for us in our actual libraries that we're using, we do more checks than this. And so for us, we actually use a lot of the to from because it gives us more ability to work with the particular items, but if you're doing simple stuff, you can do boilerplate. All right, so increment, this was one of the next ones inside of our list, so we're gonna turn around and we get our request, we get the card info, which you can see here we're putting into UCI. We have the GUID, which we're getting from the matches. So you'll notice up there we have the server put in the top right corner to kind of remind you of the endpoint that we were grabbing. And that's that regular expression where we're doing \w+, which is to capture any characters. And so that request matches 1 is actually going to take the output that is in there and stick it inside of our GUID. And so that's how you can use the combination of a little bit of regular expression with your URI to pull data off of it. And then we turn around and go back to our data store with the GUID to see if we can find that transaction. Using an optional, we check to make sure that we have a value. If we do, then we're going to turn around and do a little work on the value to add a tip. And you'll notice we have our request ID there to log out so we can track things out. We're now down looking like NCI tip amount equals UCI tip amount and NCI amount. So we're updating the amounts there. We do log save. We get our JSON back. So that JSON result equals NCI. Again, the NCI is going to use that argument-dependent lookup from the previous slide with the card info to automatically convert that to a JSON object. So it's nice and clean, and that conversion ends up happening. I think it's expressive. If you've written the to and from JSON, you understand what that code is going to do there. So we set the result or set content with the result dump and the content type. So this slide has an error on it. And I made that mistake when I was running it the first time. So I'm getting my card info and I do the data store get. I'm doing a put as an update. Anyone think what I might have missed on this one?
I'm not sure it's what you're referring to, but it scares me that you're taking unsanitized input from your request and sticking it in the database.
So you were absolutely, so the comment was that he's scared that I'm taking unsanitized input and putting it in my database, and you are absolutely right. And so to that end, that's where I will reiterate that this is a small sample app that I definitely pulled apart just to demonstrate how to do this. Definitely nothing that I would recommend for anything near production, but meant for it to be an example so you can pull it apart. What ended up catching me was that I wasn't actually storing my data back. So the first couple times I ran it, I'm like, wait, these transactions aren't being updated. So yeah, the code does work properly and I end up having it stored back. But yeah, no, this is definitely a demo app so that if you're new to this, you can pull it down, tear it apart, run the debugger on it and see how it works. All right. And evidently I had that slide in there twice. Hey? Okay. So that is this, oh. Yeah, we have our put. Okay. So now we're going to turn around and look at the client part, which we're using to test this. And I got about a little less than 10 minutes or a little more than 10 minutes left. So we'll get a quick overview of this. So you can see from the const autos, we're just setting some, some test count, a delay, content type. So httplib client, we're calling it CLI and we're passing in a URI to it. And that's really all there is to starting up the client HTTP. We're going to turn around and loop over test count times. We're going to take card info, doing initialization there and pass that in. We'll do a test post. We will then do a test put. We'll look at each of those in a minute, and then we'll sleep for a little bit of time. We're going to do a get on the interface and get our values back. And then we'll do a testing of remove to remove all the items that we posted in. But the main point here is the httplib client is actually really straightforward to create the initial connection. And then we are just passing that into each one of the methods. So if we look at the test posts, you can see we're passing in a reference to the client and we're passing in a reference to the card info. And we're going to return a card info. So you can see we have our post. So similar to how the httplib from the server side uses the verb, the client does the same thing. If you want to do a post, you do, the object.post, sale, the payload that we want to send, and the content type. We passed in a card info. By passing it over to payload, it turned it into a JSON. The payload.dump then turns it into a string, so we're just passing through a string to it. We get the response back. We turn it back into a card info, and then we're just going to output that information. For the test put, we're going to take the card info that we get passed in, and just for fun, we're going to add a 20% to the amount for the tip. And yes, very American, I know. And it's been very nice being here and not having every terminal that I helped, process suddenly add 20, 30, and 40% because that's whatever the new tip number they put on the button this week. So sale inc, and you'll notice we pass in the GUID so that we're doing an update on each one of the GUIDs. Similarly, we do the put, the path that we want it to go to, the payload, and the content type. So the get is going to turn around and do a get on the sale, and it's going to turn around and print out a list of our transactions, every transaction that we passed in. Notice there is no payload, it just does a get. But the JSON parse is going to, so the result.body is actually, a string, but we're going to parse it into a JSON, and then we'll return that. And then finally, we're going to remove the transactions, doing the same thing where we pass in the URI being sale, void, and whatever the GUID is. All right, live demo. Okay, so in our top here, as I get over there we go. So as you can see, I just did an ls-l to have this set up here. So we have this dumps folder and logs folder, and this is part of that scaffolding. We separate the two out in our own stuff. We'll end up looking at things in the logs folder, but we have 3 binaries, this RESTful, which is the actual server, and this RESTful, what I called functional test, which is our client. And so up here, I will do a start of RESTful, and you'll notice that it's just sitting. Yeah, as I just broke that, 1 sec. This is why they say you don't do live stuff, right? All right. So we're going to tail that. So you can see that we started the server up. It gave a version number. It showed what it's listening on, which in this case is all the defaults. And now you're just seeing that idle thread hit, right? Okay. And so we come down here, and then this is so you're getting a 200 on each connect. You can see us storing and increasing the count. We did our particular updates. Here we've done our get list, where it returned the particular list of all the transactions that were there. And then we went through and deleted each of the transactions too. And so I have made some slight modifications, and I fixed a few bugs from the original code. And so the code that is in the repository is more up to date than what was in some of the slides that I demoed. But it's all there and available for anyone to check out and use. And so, as I said, our logger right now is a singleton-ish. I don't dislike singletons, but as I pointed out, I have actually found where that's bit me because it's not very testable. And so that is one thing we've been working to replace. But our logger, it's been good for writing output. It's easily reachable. We don't have interleaving problems, which I know you can have from different threads accessing stuff. Injection solves some of our non-const global issues. That's where I was saying we had a lot of configuration objects that used to just be static globals. And so we were getting that as an issue. And it's one of those things that it never manifested as a problem for us, or it hasn't yet, but it is definitely one of those things that we wanted to improve on, right? The one thing that is interesting about the way we do our configurations on some of this is that if you look at the scaffolding in that app, it will reload things. So on the HTTP part, we ended up passing in as, we ended up doing dependency injection for the HTTP as I showed, in here. But on some of our items, we don't do that because we have a thread in that app class scaffolding that actually goes through and looks for configuration changes so that we can actually change an app on the fly without actually dropping it. That is, again, I didn't go over that code, but that is, the examples of that are in the scaffolding. This is where I was saying if you end up looking at some of that scaffolding code, this is the clang tidy output from the logger that's currently checked in. Yes, we know. The one we have in production is better because, we've gone through and cleaned some of those things. But for the purpose of this, like you were saying about sanitized, inputs and stuff, it's meant to be an example that you can go through and play with. If you haven't done RESTful interfaces, I hope that, this helps you get through and learn some things with it. So injection, I already spoke about that a little bit. Bridging with solid types. So this is where I was talking about earlier too, that in some cases, we used to start off just passing around, as you can see in this cortex, which is actually part of the scaffolding, we're just passing around the JSON config, and this is, in the way that we used to access it. But now we definitely find that it's better to turn things into solid types and pass around the solid type and then convert it back. It's cleaner. I think the intent is better, and you're more likely to catch yourself where you passed a string that you didn't expect to pass a string. So, speed and performance, these libraries are not the fastest. However, with them not being the fastest, we do well over $100 billion annually and over 700 million transactions in the last 10 months. And we can actually grow even 10 times this from where we're at. And it's not just by adding hardware. So it may not be, the speed that a trading firm wants, but even considering the fact that the performance of the nlohmann library or the httplib is not the fastest, they are still really easy to use and incredibly fast. The one thing I will say, the only spot that we found a real performance thing is on the HTTP client. Curl is definitely faster. So if you take the httplib, I find that easier to use than curl. But if you needed something with more speed, you can definitely use the curl API. So serving and consuming JSON with RESTful interfaces can be really simple, especially with these libraries. Cross-platform and efficient. We don't run too much stuff on Windows, but it builds either way, Windows, Linux. The example is also built on the Mac, of course. JSON definitely makes things easier to share. The amount of JSON data that you can pass back and forth, it's just easy to read. And, kind of like our logger stuff, it's funny how when you write code, you think something's really good until you suddenly go to write a unit test. and then you find yourself in a corner. So try not to do that. And so that's the URL to the repository if you want to check anything out. And thank you.